My name is Atsalam Kennedy. I am a private tutor for secondary mathematics, and I've been in this business for quite some time. For 11 years by the end of December this year, which is 2014. In the past, I used to organize a number of pupils starting from 10 to 20, and you could take them in extra lessons for mathematics. And I do normally handle both junior and senior secondary mathematics. This time around, I want to look at some problems which are commonly examined at junior level, that is grade 9. So this mathematics is meant for pupils who have attended grade 8 and 9. In most cases, it's very important to pay particular attention to understand some of these problems which I'm going to cover. And I'm going to do this via DVD video, so that someone out there watching that video CD can take advantage of watching such a program. And in the end, let me assure you that learning is going to take place. So without wasting much of your time, this time around I want to look at what can be termed as BODMAS. What is this BODMAS all about? BODMAS, this is just a sequence which we normally follow in mathematics when handling problems where you have more than two operations. What I mean by the operation, this is addition, subtraction, multiplication, and division. So what I'm trying to say is that we have the operation. This is addition, subtraction, multiplication, and division. So now if you look at the four operations, 1, 2, 3, 4. At times you may come across a question whereby more than two operations are used. So how can you handle such a problem? So without wasting much of your time, what it is that if you have 2 multiplied by 5, the answer is 10. And if you have 4 plus 3, the answer is 7. And if we can have 12 divided by 4, the answer is 3. Now, it is going to happen in such a way that you are going to be given a problem whereby two operations are going to be applied. If you look at this question, there is only one operation, which is a multiplication sign there. 2 multiplied by 5, the product is 10. Then 4 plus 3, and the sum is 7, and 12 divided by 4, the quotient is 3. Let me use a minus. Let's have also 20 minus 15, so that we can have the difference, which is 5. So if you observe very carefully, in each and every example, I have used one sign. Now, let's assume that in a situation, let's look at a different scenario whereby we are going to have a problem that is going to carry more than 2 signs. Let's say we have 12 plus 4, then divided by 2. How can you treat such a problem? Let's have a 12 multiplied by 2 minus 5 plus 1. How can you treat also such a problem? It's not always that this problem is going to have plain numbers like that. At times fractions can be used. What I want to point out is the idea of using BODMAS. What is this BODMAS all about? BODMAS. This BODMAS stands for, each letter stands for an operation. So when you look at this B means the brackets. So in that problem, do we have the brackets, open and close brackets? Then this is of. D is division, M is multiplication, A is addition, and S is subtraction. So what it is, the sequence should be followed in that direction. So whenever you confront a problem where more than 2 operations are used, that is addition, subtraction, multiplication, and division, what you have to do is to consider BODMAS. You have to check if in that problem you have brackets. If no brackets, or then the next is of division. Do you have division, multiplication, addition, and subtraction? So what it is that addition is done before subtraction, multiplication is done before addition and subtraction, and division is done before multiplication, addition and subtraction, of which you would do, if you have brackets, you have to treat the brackets before division, multiplication, addition and subtraction, like that. Like for instance, I have given two simple examples. 12 plus 4 divided by 2. So if you look at this, if you can consider BODMAS, are you going to add 4 plus 12 so that you get 16? Thereafter you divide 2 into 16 so that you get 8. Or are you going to divide 2 into 4, and upon getting a result which is 2, then you add the result to 12? That is my question. That is why I want to point out on the use of this which I have termed to be BODMAS. And this is not all that difficult. So what it is, if you confront this question, 12 plus 4 divided by 2, we have two operations, a plus, which is sign of addition, and a division. So which one comes first? We don't have brackets. Division comes first. I'm sure that is the same. Division comes first. So you have to divide first before you add. It can be a mistake to add a 4 to 12. Thereafter you divide a 2. That is not the way it should be handled. So in the first place, what you are going to do is to say 12 plus 4. And if you add 12 plus 4, what you are going to do is that, look, division comes first. You should not add the first, but what you have to do is to divide first. So in the first place, you have to say 4 divided by 2. 4 divided by 2, you get the difference, which is 2. Then after that, that is when you are going to add. So this is going to be 12 plus the result which you have obtained by dividing, because when you consider BODMAS, division comes first in that direction. So you divide 4 divided by 2, you get 2. It means 2 into a 4, it can go 2 times. So you get a 2. Then these 2 should be added to 12. And that way, 12 plus 2, then you are going to end up getting a 14. I am sure that is the thing. That is how this problem should be handled. Equally the same when you look at this 12 multiplied by 2 minus 5 plus 1. This time around we have 3 operations. The first one is multiplication there, then the second one is subtraction, and the third one is addition. So without wasting much of your time, as long as you understand that BODMAS, brackets of division, multiplication, addition and subtraction. So which comes first? Brackets, we don't have brackets. Division, we don't have anywhere the sign of division. Multiplication, so multiplication comes first this time. So which means you have to multiply first before you consider the other operations. So in the first place, you multiply 12 multiplied by 2, you get a 24, like that. Then this is followed by minus 5, then followed by plus 1. Then you have already treated a multiplication first. So this reduces by multiplying 12 by 2, you get 24. And this is minus 5 plus 1. So negative 5 plus 1, which means this is the sign of subtraction, this is the sign of addition, which comes first between subtraction and addition. So BODMAS, brackets of division, multiplication, addition and subtraction. So you have to add the first. Even if this 5 is immediate after 24, you should not subtract. You have to add first. I'm sure that is understood, because addition comes first when it comes to consider subtraction and the addition. According to the sequence BODMAS, addition comes first. So BODMAS, multiplication, addition and subtraction. So this is addition and subtraction. So you have to add first. So what you have to do is you have to say 24, then you add plus 1. Thereafter minus 5. I'm sure that is understood. 24 plus 1, which is 25. And this 25 minus 5. And 25 minus 5, you end up getting the result, which is going to be 20. So the result there is 20. I'm sure that is understood. Even if you use a scientific calculator is going to give is not going to show you the order on how to. What you are going to do is just to feed 12 plus 4 divided by 2. Then you press an equal sign. Then you get the feedback. So there it is. If a scientific calculator is on, it displays a 0. So what I want to feed is 12 plus 4 divided by 2. So there I am, 12, then followed by plus 4, then followed by divided by 2. That order equals, as you can see, that is what a calculator, that is the answer given by a scientific calculator, which is 14. But it's not always the case that every time you are going to be using a scientific calculator. Without using a scientific calculator, this idea or the sequence of BODMAS must be taken seriously. So without wasting much of your time, same applies where you have 12 multiplied by 2 minus 5 plus 1, so that the result can be a 20. So you create a scientific calculator, 12 multiplied by 2, so there I am 12 multiplied by 2, then followed by minus 5, then followed by plus 1, then equals. As you can see, if a calculator can be fed in that order, 12 multiplied by 2 minus 5 plus 1, the result is 20. So this order of BODMAS is very important. It's not always that it must be used with numbers like that. Even fractions can be treated equally the same. Whenever you confront a problem where you have more than 2 operations, that is what you should do. Let us look at many more. This time let us look at some examples which are going to include or which are going to involve fractions. But you have to bear in mind that that BODMAS, you have to understand how the sequence is followed. Whenever more than 2 signs or operations are used in that particular problem, then you have to take BODMAS seriously, or rather you have to take BODMAS into consideration. So for instance, let's look at this example where we have 1 over 4 plus 3 over 2, then minus 5 over 3. Let's have this one, which is 7 over 30 minus 4 over 15 divided by 1 over 3. So if you look at the 2 examples, these 2 examples are not all that difficult. I call this as A and I call this as B. So without wasting much of your time, what you have to bear in mind is that if you look at the first problem, I called the first problem, which is 1 over 4 plus 3 over 2, then minus 5 over 3. If you look at this problem, these are fractions, but what is important is that there are 2 operations used. There is a plus, which is sign of addition, and there is a minus there. So what you have to do there is that you have to be very careful. You have to employ what I have termed to be BODMAS. BODMAS, brackets of multiplication, addition, and subtraction. So there are 2 operations used there. There is the sign of addition and the subtraction. So if you look at that in that order, in that sequence, addition comes first, followed by subtraction. So you have to add first before you subtract. I'm sure that is understood. And for sure, if you add 1 over 4 plus 3 over 2, so this is 1 over 4 plus 3 over 2. The common denominator is a 4 there. 4 into a 4, it's 1. 1 times 1, it's 1. Then plus 2 into 4, it's 2. 2 times 3, it is a 6. So this is 1 plus 6, it is a 7 over 4. I'm sure that is C. So if you add these 2, you get a 7 over 4. So by adding these 2, 1 over 4 or plus 3 over 2, this is 4. 4 there, 1. 1 times 1, it's 1. Plus 2 into 4, it's 2. 2 times 3, it is 6. So this is 1 plus 6, it is 7 over 4. Then upon getting this 7 over 4, you have to proceed. You subtract I carry forward this, I cut down that, which is 5 over 3 to be subtracted into that sum. 5 over 3 to be subtracted from there. As you can see, the way we subtract 7 over 4 and 5 over 3, you look at the denominator, this is 4 and 3 down there, which means that you have to look for the smallest number in which a 4 and 3 can divide into without leaving any remainder, and that number is a 12. The number is a 12. So 4 into 12, it is 3 times. 3 times 7, it's 21. Then minus 3 into 12, it's 4. 4 times 5, it's 20. So from there, as you can see, this leads to 21 minus 20, you get a 1, and this is 12, just like that. It can be a mistake to start by subtracting 3 over 2 minus 5 over 3. Thereafter, the result to be added to 1 over 4. You have to consider that sequence, BODMAS, brackets of division, multiplication, addition and subtraction. So addition comes first. Then what comes next is subtraction. So in this problem we have addition and subtraction sign. I'm sure that is understood on how BODMAS can be used. And I'm emphasizing that this must be put into practice. Most of you out there do complain to say mathematics is a difficult subject. Mathematics is not a difficult subject, but simple and straightforward. Only that in mathematics requires a lot of practice, and it's only by practicing that you are going to end up developing better skills. So without wasting much of your time, allow me to move on so that I look at the second example, which is 7 over 30 minus 4 over 15 divided by 1 over 3. How can this problem be treated? It can be look at the blackboard. This is the question, and there are two operations used, a minus and a division, and it involves fractions, of which for this question to be answered properly, you have to include the BODMAS. BODMAS, B-O-D-M-A-S. Each letter stands for an operation. D is for division, M is for multiplication, A for addition, and S for subtraction, whereas B is for brackets. B is for the brackets, open and close brackets. So in that order, whatever comes first must be considered first, or must be accommodated first. So without wasting much of your time, if you look at a minus and division, which comes first? Brackets of division comes first. So what it is that you have to divide first. You have to look at this 4 over 15 divided by 1 over 3. Thereafter, the result is the one which is going to be subtracted from 7 over 30. I'm sure that is understood. So if you get 4 over 15 divided by 1 over 3, what it is there is that this is division. Division can be changed to multiplication. So you maintain 4 over 15, then change multiplication to division to multiplication. Then it means the second fraction, which is 1 over 3, should swap. 3 is going to take the position of 1 and 1 takes the position of 3. So this is 3 over 1 like that. Then from there, as you can see, if you want, you can multiply 4 by 3 and 15 by 1. Or you can cancel 3 there, it's 1, and 3 into 15, it is 5. So 4 by 1, you are going to get a 4. And 5 by 1, you get a 5. So what it is that when you divide 4 over 15 divided by 1 over 3, you are going to get 4 over 5. So it is this 4 over 5 which is going to be subtracted from 7 over 30. So let me transfer the question there. This is 7 over 30 minus 4 over 15 divided by 1 over 3. You have seen that this is 7 over 30 minus. You have seen how I have treated 4 over 15 divided by 1 over 3. 4/15 divided by 1/3, so that I arrive at 4/5. So it is this 4/5 which must be subtracted from 7/, which must be subtracted from 7/30. Let me write properly there. So now what it is there is that you draw a dividing line. So from there, what you are going to do is that you look for a number in which a 5 and 30 can go into without leaving any remainder. The smallest number is 30. So 30 into 30, it's 1. Then 1 multiplied by 7, you get a 7 there. Then you bring down a minus. 5 into 30, it is 6. Then 6 times 4, it's 24. So as you can see, 7 minus 24. What can be the difference between 7 and what can be the difference between 7 and 24? So this is going to be 7 and 24. This is going to be 17, which is a negative. It is this negative 24 which has subtracted the 7, negative 17 over 30. I'm sure that is understood. So this idea of following BODMAS or considering BODMAS is very important. For sure, if you can handle this problem differently, that is by subtracting 4/15 from 30, thereafter you divide 1/3. You are not going to end up getting a wrong answer. So this must be practiced. Let me add 2 more examples, and after that I move on to some other problems that can be examined. There are 3 more examples. The first one is that you have 1/4 multiplied by 2/3 plus 5/12. The second one is 2/3 divided by 5/6 minus 1/5. And the fourth one is the one involving mixed fractions. This is the 3 and 3/4 divided by 1 and 1 out of 6, 1 and 1 out of 6 minus 3/8. So such problems, this is where when you confront such a problem, then you can not solve such one of these problems without applying BODMAS. So how do we apply BODMAS? So far so good. You have learned 1 or 2 things on how BODMAS can be applied. So let me start from the first one. Let me call the first one as question A. I call this as question B and call this as question C. So let me start from equation A, which is 1/4 multiplied by 2/3 plus 5/12. In the first place, I have to write BODMAS somewhere. So looking at that, I look at the 2 signs. There is multiplication sign there, and the multiplication sign and the addition sign. So multiplication and the addition, when you look at these 2, which one comes first? Brackets of division, addition. Brackets of division, multiplication, addition, subtraction. Addition comes last. As you can see, there is multiplication before addition, and there is a multiplication sign. So in the best you are going to do it is to multiply the first 2. As 1 multiplied by 2, you get 2 over 4 multiplied by 3, you get a 12, like that. Thereafter, upon multiplying 1 by 2, you get a 2. 4 by 3, you get a 12. Then after that, you have combined the 2. Then you can proceed to say plus 5/12. The common denominator is a 12. What it is that since the common denominator is the same, what you are going to add is 5 plus 2, you get a 7 up there, then over 12. Since the common denominator is just the same, so you have to maintain it. Others may think of adding this as 2/12 plus 5/12 by taking that 12 to be the lowest common multiple. 12 into 12, it's 1. 1 multiplied by 2, it's 2. Plus 12 into 12, it's 1. 1 multiplied by 5, it's a 5. As you can see, 2 plus 5, you get a 7. And this is over 12. So whenever you have the same denominator there, what you have to do is just what is up there, 2 plus 5, and you get a 7. Then you maintain that this is out of a 12. I'm sure that is understood. That is how the first problem can be treated. So without wasting much of your time, allow me to look at the second problem, which is a B. And this goes 3 divided by 5 over 6 minus 1 over 5. So in the first place, allow me to copy this problem. This is 2 over 3 divided by 5 over 6 minus 1 over 5. So first of all, you look at the signs which are involved. There is a division there and the subtraction. So if you can follow that order, there is division and the subtraction. BODMAS, brackets of division, multiplication, addition, and subtraction. As you can see, division comes the first. So we have to divide the first before we can subtract. And this can be in the first place. I have copied the question. 2 over 3 divided by 5 over 6 minus 1 over 5. So upon examining BODMAS in that direction, you find that division comes first. So I have to divide first. So I look at this, which is 2 over 3 divided by 5 over 6. The rule is that I maintain that this is 2 over 3. This division changes to multiplication, and if you do that, then 6 can be written up and 5 comes down like that. Then from there, if you want, it can be reduced from there. If you want, you can multiply 2 by 6 to get 12, and 3 by 5 to get 15. Thereafter, you look for a common number that can be divided into a numerator as well as the denominator. Or if you don't want to do that, just from there, it can be seen clearly that 3 can go there once, and 3 can go into 6 twice. Then from there, 2 multiplied by 2, you get 4. And 1 multiplied by 5, you get 5. So it is 4 over 5. I'm sure that is understood. But the other way to do it without reducing it, you can say 2 multiplied by 6, you get 12. Over 3 multiplied by 5, you get 15. And upon getting 12 over 15, what it is that you have to look for the number which can be divided into 12 and as well as 15 without leaving any remainder. All I'm saying is that before reducing it, 2 by 6, you get 12, and 3 by 5, you get 15. So look for a common number that can go into 12 and 15 without leaving any remainder. And that is 3. 3 into 12, it is going to be 4, and 3 into 15, it is going to be 5. The choice is yours. So looking at that, when you divide this, the first 2, 2 over 3 divided by 5 over 6, and this reduces to 4 over 5. I'm sure that is seen. You have seen how I have derived that to 4 over 5. So this is 2 over 3 multiplied by 6 over 5. And after that, you multiply 2 by 6, you get 12. And 3 by 5, you get 15. Mind you, all fractions must be reduced to their lowest terms. So this 12 over 15, you have to divide the 4 into 12 3 times, and you have to divide the 3 into 12 so that you get a 4, and the 3 into 5 so that you get a 5. So this is 12 over 15 is the same as 4 over 5. I'm sure you have seen how I have arrived at that 4 over 5. So upon getting this, which is 4 over 5, then you have to bring down this, which is 1 over 5, and it is this 1 over 5 which is going to be subtracted from the fraction which you have obtained by dividing 2 over 3 by 5 over 6. You have seen the procedure. This is the process until I get to 4 over 5. And it is this 4 over 5 which is going to subtract 1 over 5. I'm sure at this point in time that is understood. And everything is out of 5. This is 4 over 5 and this is 1 over 5. So to simplify the matters, 4 minus 1, you get a 3, and this is over 5, just like that. Since the common denominator is the same, even if I say the common denominator is 5, I say 5 into 5, 1. 1 times 4, I get a 4. Minus 5 into 5, it's 1 times 1, I get a 1. Up there, I'm going to have 4 minus 1, which is going to reduce to 3 over 5. The reason why I have subtracted the directly as 4 minus 1 to get a 3 is because that I have a 5 there. This is out of 5 and that is out of 5. I'm sure that is understood. That is how the second problem should be handled. This is not all that difficult, but simple and straightforward. What is important is that the little you learn must be put into practice. Coming to question C. Question C includes mixed fractions. There is 3 over 4 divided by 1 over 6 minus 3 over 8. I have to copy the question in the first place. This is 3 a whole number, then 3 over 4 divided by 1, then 1 out of 6 and minus 3 over 8. So what is important is that I have to look at the signs that I used. I said whenever you can have 2 or more signs, then body mass must be considered. So we have the 2 signs, division and subtraction. So which comes first? In that sequence, as you can see, division comes first there, then followed by subtraction. In fact, the subtraction is the last sign to be applied because it comes even after addition. So without wasting much of your time, you have to divide first. So dividing first, looking at this 3, looking at this, which is 3 over 4 divided by 1 over 6. So what you are going to do is that you have to copy the question 3 then followed by 3 over 4 divided by 1 out of 6. So in the first place, change the mixed fraction into improper fraction. I am saying into improper fraction in such a way that the bigger number is going to be up and the smaller number is going to be down. So it can be better to change it in that form. So this is 4 multiplied by 3, you get a 12. Then 12 plus 3, you get a 15. So up there you have a 15. Then you maintain this is out of 4 because what is down there is a 4. I've just multiplied 4 by 3 to get 12. Then 12 plus this 3, and I have obtained this 15, which is up over 4, so that it can be in an improper fraction. I maintain that this is division. Then 6 multiplied by 1, it is 6, plus 1, it is a 7. So this is a 7 over 6. I'm sure that is understood. Then let me combine minus 3 over 8. Still, the order is that we have division and the subtraction. And still, division comes first. So I have to divide these 2 first. Aside, I get this 15 over a 4 divided by 7 over a 6. So I maintain 15 over a 4. Then multiplied by, mind you, I have changed this division sign to a multiplication sign. So that even the fraction which comes after should swap. A 6 moves up and a 7 comes down like that. Then from there it's up to me. If I want, I can multiply this 15 by 6 to get that number, and 4 by 7. Thereafter I reduce that fraction. But it can be better to reduce from there. There is a 6 there and a 4. 2 into 6, it is 3 times. And 2 into 4, it is 2 times. Then from there, 15 times 3, I get 45. And 2 multiplied by 7, I get a 14. So this is 45 over 14. So combining these two, I get 45 over 14. Then after that, 3 over 8 must be subtracted. Minus 3 over 8. I'm sure that is C. Then from there, what I'm going to do is that I look for a number in which a 14 and 8 can divide into without leaving any remainder, and that must be the smallest number. And this is the smallest number is 56. So the smallest number is 56. You find that when you divide the 14 into 56, you are going to, it is going to divide there 4 times. Then 4 multiplied by 45. that is going to be 180. 4 by 145, 180 minus, then 8 into 56, it is going to be 7. 7 by 3, you get 21. Thereafter, 180 minus 21. And the 180 minus 21, there it is 180 minus 21. So this is 10 minus that is 9. This is 7 minus 2 to 5. And this is 1. So the difference is 159 divided by 56. 159 divided by 56. So how many times can 56 go into 159? So you have to figure it out there. How many times can a 56 be divided into 159, so that the answer can be given as a mixed fraction? Because from the beginning, the question has shown some mixed 159 divided by 156, and this is going to be 2 times. So you write 2, remainder 47 over 56. I'm sure that is seen 2, a whole number, and then 47 over 56. That is a mixed fraction. There is a reason why I have left the answer in a mixed fraction form, because from the beginning, if you look at the question, it has some mixed fractions. So upon getting an improper fraction there, I have divided to get that. I'm sure that is understood. 156 into 159 divided by 56. 56 can go there 2 times. Then the remainder is 47 over 56. So that is how body mass can be. That is how body mass can be used. Without wasting much of your time, let me take you some steps further in mathematics. And this time around, let us look at some more mathematics which can be examined at grade 9. So let us look at angles in a straight line and angles in a triangle. Both angles in a straight line, if you can add the angles inside the triangle, you have to get the sum of 180 degrees. And again, if you add the angles on a straight line, in a straight line, then you have to get 180. So allow me to give a few examples about the same. Look on the board. If I draw this line, this is a straight line, and again this is a triangle. I've got a straight line and a triangle. So what it is, if I can have a point there, then I divide this straight line into 2 angles in such a way that this is angle A and angle B. Then what it is that A plus B, I have to get 180 degrees. And again, if you look at this is X, this is Y, and this is Z. X plus Y plus Z. I have to get the sum, which is 180 degrees. So angles inside the triangle add up to 180, and angles on a straight line add up to 180. It's not always the case that a straight line can be divided into 2 equal parts or 2 different parts. At times it can be divided into several portions. Let's say this is X, this is Y, and this is 40. So what it is that if these 3 angles can be added, X plus Y plus 40, you have to get 180. X plus Y plus 40, you get a straight line which is 180. So this is X plus Y plus 40 degrees, you get 180 degrees, of which at a later stage this problem can be, this equation can be solved. Same applies to a triangle. Let's have, for instance, if this is a triangle and this angle is given to be 40 degrees, whereas this is given to be 60 degrees, then there we have X. Then automatically examiners are going to ask you to say, find the size of angle X, find X. And one of the angles is 40 degrees, that is 60, and that is 80 degrees. Knowing very well that 3 interior angles inside the 3 interior angles of a triangle I'm saying 3 interior angles, which means the 3 inside angles of a triangle add up to 180. So what you have to do is that you add the 40 plus 60 plus x, then you get 180, and that equation must be solved. So this goes as 40 plus 60 plus x, and this is equals to 180. 40 plus 60, you get a sum of 100, then plus x, and this is equals 180 degrees. Then from there, this is now x equals 180. If this 100 crosses the equal sign, it becomes minus. This time it's a plus. It crosses minus 100, and this way x is equals to 180 minus 100. You get 80. So the size of the angle or x is 80 degrees. So that if the 3 angles can be added, you get 180 degrees. I'm sure that is seen, and at the same time it can be observed in a similar style. Let's assume that where we see x there, let's have one angle which is 50 degrees, and that way you'll be questioned to say find the size of angle y. To find the size of angle y, find the size of angle marked y. So what it is that you are going to add, this is the 50 plus the y plus 40, the 3 angles that makes up a straight line, and this is equals to 180 degrees. Then from there, what you are going to do is that you correct the right terms. This is 50 plus 40, then plus the y equals 180. Then from there, 50 plus 40, this is 90, plus the y equals 180. Thereafter, y is equals to 180. After an equal sign, you have 180. If this positive 90 crosses the equal sign, becomes minus 90 degrees, like that. And that way, y is equals to, I'm sure that is seen, y is equals to 180 minus 90, and you are going to get a difference which is 90. So this time around, y is equals to 90 degrees. I'm sure that is understood. So without wasting much of your time, it may happen that these straight lines for a triangle can be extended. If this is extended, then there is an angle which is formed there. I'm sure that is understood. If that is also extended, there is an angle which is formed there. And if let's say this is extended, there is an angle formed there. So these angles, these 3 angles which are formed, are what can be said to be the exterior angles. Mind you, x, y, z, these are interior angles because these are the inner angles. They are found inside the triangle. But those which are outside, which are formed as a result of extending or producing a line, are said to be exterior angles. I'm sure that is understood. Now what it is that if this is going to be A, this is going to be angle B, and this is going to be angle C. So it follows that AA plus B plus C, you have to get 360 degrees. I'm sure that is understood. You add interior angles, you get 180. But if you extend each and every line so that you get each of the 3 exterior angles, then if you can find the sum of the exterior angles, then the sum should go up to 360 degrees. I'm sure that is understood. So without wasting much of your time, that is what the idea. Let's assume that here I extend the line like that. Then there we have x. Let's have a y there. So the question can be find the value of x and y. Quite okay. To find the value of x, we have added 60 plus 40, then plus x. So at 60 plus 40, it's 100. 100 plus the x, and this is 100 plus x, which is equals to 180. And solving the equation, x, this 100 crosses the equal sign so that it can be subtracted from 180, so that x becomes 80. And if x is equals to 80, what can be the value of y? The value of y is going to be 100. The method which you can use is that of a straight line. A straight line adding up to 180. Already we have got this x to be 80 degrees. So what you are going to do is to say x plus y equals 180 for a straight line. X plus y equals 180. I have to show that one. x plus y equals 100, and to say is that when you look at that, we have already obtained that this is x plus y, which is equals to 180, a straight line at that point there. I'm sure you have seen it there. X plus y 180, of which by adding 60 plus 40 plus x, I've got 100 plus x, of which x is obtained to be 80. You have seen how x is obtained to be 80. So what you are going to do there is that to substitute. In place of x, you write 80 plus y equals 180. I'm sure that is understood. And y that way is going to be 180 minus 80, and y this way is going to be 100. I'm sure that is understood. That is how y can be obtained to be 100. I have raised an important factor to say that the three exterior angles add up to 180, whereas the interior angles add up to 360 degrees. There is a triangle. Let's assume that this is protruded and this is also protruded, or rather extended. This line is extended and that line is extended. Now, knowing very well that this is 60, this is 40, and this is 80. So what it is that if this is 80, straight line, subtract 80 from 120, this is going to be 100. And this is the first exterior angle. This is 60, 60 from 180 for a straight line there. This is going to be 120. And this is a straight line there. Subtract 40 from 180 so that you get this angle. 40 from 180, you get 140. So if you observe very carefully, you have three exterior angles. The first one is 100 there, followed by 120, followed by 140. So for sure, if you can add the exterior angles, 140 starting from this angle, plus 100, plus 120 there. This is going to be 360. Mind you, 140 plus 100, you are going to get 240. 240 plus 120, you get 360 degrees. These are the exterior angles, the outside angles. I'm sure that is understood. But for interior angles, 60 plus 40 plus 80, you get 180. So this is 60 plus 40 plus 80, you get 180. These are the interior angles, inside angles. You get 180. But for exterior angles, you get 360 degrees as a sum. Now, from that, it can be seen clearly that if you look at this setup, it can be seen clearly that if you want to find an exterior angle there, all you need to do is to add these two interior angles. You add 40 plus 60, you get y. So y is equals to 40 plus 60, and y is equals to 100 degrees. I'm sure that is understood. Same applies. If you extend this line, then it means that the one which is extended is there, then you cover that, then you have to add 80 plus 40, then you are going to get 120. Same applies. If this is the one which is extended, then it means you cover the 40 there, then you add 80 plus 60, and you are going to get 140. These facts are very important and they must be taken into consideration. You find that when solving the triangles, these are some of the tricks which you normally apply. Failure to keep this information in mind, it becomes difficult to work out a triangle where angles are concerned. I'm sure that is understood. Allow me to give some few examples so that we see how we can fix some of the angles inside the triangle. Or for example, for this example, we have a triangle whereby the interior angles are 70 degrees, 40 degrees, and x degrees, whereas this is a y. Automatically, for such a problem, you are going to be told to say find the size of angle marked one x and 2 y. So find the size of angle marked x and the angle marked y. This is not all that difficult, but simple and straightforward. What you have to do there is that you have to understand the properties of the triangle carefully. That 3 angles of a triangle add up to 180, and at the same time the 3 exterior angles of any particular triangle add up to 360. So if that can be ringing in your head, and again you have to consider that angles on a straight line add up to 180 degrees. Then if you have revised properly on those lines, it cannot be difficult to find the size of angle X as well as angle or Y. So without wasting much of your time, in the first place, to find the angle X, you have to consider the 3 angles of a triangle add up to 180. So you have to add X plus 40 plus 70, and this is equal to 180 degrees. That is how you can find the angle X. So that way, this is going to be X plus 40 plus 70, 0 plus 0 is 0, then 4 plus 7, that is 11. So this is 110 degrees. Then this is equals to 180. Then from there, this is X equals 180. If this 110 crosses the equal sign, it should be subtracted from 180. So this is 110. So this is X is equals to 180 minus 110, which is equals to 70. So as you can see, X is represented by 70 degrees. And this is not all that difficult, but simple and straightforward. If X is equals to 70 degrees, let's assume that 70 plus 70 is 140, then plus 40 you get 180. Now, if X is equals to 70, can it be difficult to work out the size of angle Y? Angle Y, it's not all that difficult. There, what we see is a straight line. So for a straight line, what you are going to do is that you are going to say Y plus X is equal to 180. And this is for a straight line at that point. So from there, this is Y plus X is obtained to be 70, and this is equals to 180, and Y is equals to 180 minus 70, and that way Y is going to be 110. This is the first method that can be applied, or rather the first alternative. There can be some other ways of getting the value of Y. Getting the value of Y, since this Y is an exterior angle at that point, then it means that if I cover an interior angle there, I need to add these 2 angles, 70 plus 40, then I get the size of angle Y. So angle Y can be found by Y is equals to, I add 70 plus 40, and this is angle Y, which is 110. All these must be put into practice, and it can be seen clear that I cover that X, I add these 2, then I get the exterior angle. Same applies if these 2 were to be extended. To get the exterior angle there, I were to cover this 40 there, then I add there X plus 70, then I get that exterior angle. Same applies if this were to be extended, to be a straight line, extended or produced, so that I can have an exterior angle there. Instead of subtracting this 70 from 180, so that I get 110 there, all I need to do is to cover this 70, then I have to add 40 plus X. This is 40 plus X, of which X is obtained to be 110. So, of which X is obtained to be, of which X there is obtained to be 70, which means 40 plus 70, and you are going to get 110. Same applies if you consider a straight line like that. So these facts which I have offloaded are very important. Whenever you confront a triangle, you have to think in those lines, and that way you are not going to find a triangle, or rather a straight line, to be difficult to handle. So without wasting much of your time, allow me to take you some steps further in mathematics. Like I said earlier on, that this mathematics is meant for people who are in triangles of different types. There is what we call an isosceles triangle, and for this isosceles triangle, the 2 angles are equal and the 2 sides of lengths are equal. Then there is the equilateral triangle. For an equilateral triangle, all the edges are equal, all the three sides are equal in length at the same time, all the three angles are equal, you find that for an equilateral triangle, each and every angle is equal to 60 degrees. So that if you can add the 360s, then you are going to get the sum of 108. And again, there is what we call a scaling triangle, whereby for this scaling triangle, all the three angles are totally different from the other. So without wasting much of your time, allow me to look at the types of triangles. The isosceles triangle. The spelling for the isosceles triangle. First of all, I draw a picture for an isosceles triangle. If you see a triangle like this one, whereby there is that and that, it means that this side and that side are equal. Then it means that these two angles are going to be equal. If this is A, this is also A. The one which is going to be different is this one. Maybe let's say this is 70 degrees. So such a triangle is called an isosceles triangle. So the spelling for an isosceles triangle, it is ISOS C ELES. This is isosceles, and the isosceles triangle. Then for the isosceles triangle, it has two equal sides and two equal angles. As you can see, this is angle A and that is angle A, and that is the angle which is different. So to give an example for an isosceles triangle, you find that if this angle is 40 degrees, if this angle is let me say if this angle is 70 degrees, this is also going to be 70 degrees, meaning that these two sides are equal. So such a triangle is an isosceles triangle. So to get the third angle, 70 plus 70, you get 140. Then 140 from 180, you are going to find that this is going to be 40 degrees. Such a triangle is an isosceles triangle. At times, the two isosceles triangles can be joined together, like you join the two isosceles triangles together, this and that equal, and let's assume that this and that are also equal. Then two isosceles triangles join together to get a kite. If let's say this is 70 degrees there, and this is also 70 degrees there, and what is different is this which is 40 degrees, 7 plus 70, 140. Same applies. This is another isosceles triangle joined to another isosceles triangle. You may find that there you are going to have x, even there x, and this one you are going to have 140 degrees. And that way it cannot be difficult to find the size of angle x. All you are going to do is to add, as long as you identify that this is an isosceles triangle, x plus x, then plus 140, and this is equal to 180. So to find that x, what you are going to do is you subtract 140 from 180, then you get 40. Then 40 divided by 2, because these are two are equal. So each is 20. So this is 20 degrees and that is 20 degrees. But if you want, you can solve that equation. X plus 140 equals 180. So x plus x, you get 2x plus 140, and this is equals to 180. So this is 2x is equals to 180 minus 140, and this is 2x is equals to 180 minus 140. You are going to get 180 minus 140. You are going to get 20. You are going to get 40. So mind you, this is now 2x is equals to 40. So when you have 2x is equals to 40, let me transfer that. There, this is 2x is equals to 40. So what you are going to do is that over 2 this side and over 2 this side. So 2 and 2 cancels, then x is equals to 2 into 40, you get a 20. So x is equals to 20. But here I have shown a picture whereby an isosceles triangle and another isosceles triangle joined, so that you can come up with a shape which is a kite. I am sure that is understood. The first one is an isosceles triangle. Then let us look at another type of a triangle, and this type of a triangle is called an equilateral triangle. For an equilateral triangle, all the three sides are equal and all the three angles are equal. you find that if this is angle A, this is also angle A, and that is angle A, meaning that this and that are all equal in length. If the length of the first line is 10 centimeters, from there to there, even this should be 10 centimeters, that to be 10 centimeters in those lines. So to find the size of angle A, it's not all that difficult. What you are going to do is to add A plus A plus A, and you get 108. So A plus A, this is 3A equals 18. So what you are going to do there is you divide the 3 there and the 3 there. 3 and 3 cancels, then A comes to 3 into 18, it is 6. 3 into 0, 0. So A is equal to 60 degrees. So for an equilateral triangle, the name equilateral triangle comes from equal. It has got all the 3 angles that are equal. At the same time, it has all the 3 edges that are equal. That's why it is called equilateral triangles. So let me write equilateral triangles. So this is equilateral. This is equilateral triangle. All the angles are related and all the sides are related. So I have said it to say for equilateral triangle, it has 3 equal sides and the 60 degree angles. You have seen for yourself that if this is 60 plus 60 plus 60, then you get 180 degrees. That is an equilateral or triangle. So let us look at another type of the triangle, and this is a scalene triangle. For a scalene triangle, you should expect angles of a scalene triangle to be totally different. For a scalene triangle, you find that the size of the first angle is totally different from the size of the second angle, as well as the size of the third angle. Such a triangle is said to be a scalene triangle. Allow me to clear some space so that I show what is triangles. Scalene triangles, where we have all the 3 sides that are totally different. A triangle like this one, whereby if I can demonstrate, this is X, this is Y, and this is Z. I am using 3 different letters to show that even these angles are totally different. An example of a scalene triangle is where we can have this angle to be 40 degrees, this other one to be 20 degrees, whereas the 40 plus 20, that is 60, meaning that this other one is 120 degrees. Such a triangle is said to be a scalene triangle. Even when it comes to edges, these are totally different in lengths. You find that this can be 5 centimeters, the other one is 6 centimeters, and the other one is 10 centimeters. They are all different. I'm sure that is understood for a scalene triangle. Then another one is what we call a right-angled triangle. What is this right-angled triangle? Right-angled triangle. I'm talking about the types of triangles. The right-angled triangle is where you have one of the 3 angles to be 90 degree angle. You find that if this is 90 degrees, such a triangle is a right-angled triangle. A right-angled triangle. It can be drawn that way. As long as one of the 3 angles is a 90 degree angle, then that triangle can be named to be a right-angled triangle. You may find that if this is 60 degrees, so what it is for a right-angled triangle is that this angle and the other angle add up to 90 degrees. So 60 from 90, this is 30. So 30 plus 60, 90, then plus 90. For 3 angles you get 180. Same applies. If there you have X and this is Y, then it means X plus Y. This is equal to 90, as long as this is a right-angled triangle. I'm sure that is understood. And again, if you can add all the 3 angles of a triangle, you have to still get it. You may find that a triangle like this one, where you have one angle which is more than 120 degrees, instead of falling under a scalene triangle, it can be called an obtuse a triangle, meaning that one angle is more than 90 degrees. Whereas a triangle like this one, where you can have all the angles that are less than 90 degrees. Let's say this is 80 degrees, then this is 40 degrees. 80 plus 40, you get 120, and this other one is 60 degrees. Instead of calling it to be an obtuse triangle, there is no angle which is obtuse, but all these angles are acute angles. Those which are less than 90 degrees are said to be acute angles. Such a triangle is called an acute angled triangle. An acute angled triangle. Meaning that all the angles are less than 90 degrees. But this one with the one angle which is more than 90 degrees is said to be an obtuse angled triangles. Obtuse angled triangle. I'm sure if you have been following, you have learned the types of triangles. This is a right angled triangle whereby you have a 90 degree angle, or there, of which for a right angled triangle it should come to your mind that apart from agreeing to that three angles of a triangle add up to 180. This is 90 plus x plus y equals 180. It can be accepted also that if it is a right angled triangle, that the x plus y must be add up to 100 and must add up to 90 degrees. So these two 90 degrees plus this 90, then you get 180. So for a right angled triangle, once you identify that the triangle is a right angled one, just bear in mind that these two opposite angles should add up to 90 degrees. But the three angles, x plus y plus 90, add up to 180 degrees. So as you can see, x plus y 90 degrees. Let me show that if you can add the three angles there, this is x plus y plus this one which is 90, then you get 180 degrees. But if you add these two, you get 90 degrees. Equally the same, if you look at this, there is a 90 there, a 90 plus 60 plus 30, this is equals to 180 degrees. But if you can add this and that, which is 60 degrees plus 30 degrees, you will get 90 degrees. So these two opposite angles for a right angled triangle add up to 90 degrees. I'm sure that can be observed. So without wasting much of your time, let us look at some number of questions pertaining to triangles. So let us look at some few questions pertaining to triangles. The first one goes the first triangle, whereby it's a right angled triangle. I have identified it to be a right angled triangle. Reason being that this angle there is an indication there that this is 90 degrees. This is 68 degrees, and that is A. So for this question, you can be questioned to find the size of angle A, since the size of the size represented by letter A is not known. So to cut short, let me say find A. But for this second one, let me say find X. So what you have to do for the first one is that there are two ways of doing it. Method one, identifying this that it is a right angled triangle. What you have to do is that these two angles add up to 180. It can, since it is a right angled triangle, method one, what you have to do is that 68 degrees plus angle A, this is equals to 90 degrees. This one being that three angles add up to 180. I subtract 90 from 180, the sum remains to be, the remaining angle is 90. So meaning that this and that add up to 90 degrees. That is method one. So this way A is equals to, this is 90 degrees minus 68. So A is equals to 90 minus 68. Mind you, this is 10 minus 8, it is 2. I've taken a 1 there. This is 8 minus 6, it is 2. So A is equals to 22. So the size of angle A is 22 degrees. Coming to, before I come to the second one, I have to look at the second method. This is method one. The second method is that I am going to add all the three angles to add to 180 degrees. And these are interior angles, 68 plus 90 plus A. So this is the 68 degrees plus 90 degrees, 68 plus 90, then plus A, which is an unknown angle, and this is equal to 180 degrees. The fun part is, the trick part is that if you add all the three angles, then interior angles you have to equate 90 degrees. But if you add the two angles, 68 plus A, you have to say equals 90. I'm sure that is understood. Then from there, 68 plus 90, 8 plus 0, you are going to get 8. Then 9 plus 6, you are going to get 9 plus 6, you are going to get 15. So this is 158. Then followed by plus A equals 108. What I have done is that the sum of 68 and 90 is 158. Then plus A equals 180. So from there, this is going to be A equals 180 minus 158. Then that way A is equals to, I get 1 and add to that, this is 10. 10 minus 8, it is 2. Then what remains there is a 7. 7 minus 5, it is a 2. And this is 1 minus 1, which is 0. So this is 22. Again, it can be seen clear that A is equals to 22. This is for the first diagram. But for the second one, there is only one option, whereby if you add all the three angles of the triangle, then the sum should come to 180 degrees. So what you have to do is to add 2x plus 3x, then plus x. Then you have to get 180. And this can be done as follows. So the first angle there is 3x. So I have to write 3x plus the second angle there is 2x plus 2x. Then followed by plus x. And this is equals to 180 degrees. Then from there, 3x plus 2x plus x. 3x plus 2x, 5x plus x. And this is 6x. And this is equals to 180 degrees. And that way, 6x is equals to 180. Then from there, over a 6. There, again, over a 6. A 6 and a 6 cancels. Then x is equals to 6 into 18, it is 3. And that into that, it is 0. So x is equals to 30, which I have calculated is just the value of x according to the equation. But if it means to find the size of which angle, then it means that where we see x there, it means we have 30 degrees. Where we see x there, it means this is 30 degrees. And there where we see 3x, it means 3x, it means 3 multiplied by 30. And this is 90 degrees. And where we see 2x, 2 multiplied by 30, this is 60 degrees. So that if you can add the 60 plus the 30 plus 90, you can get 180 degrees. So such a triangle, even if it is in that nature, it is a right angled triangle, because somewhere where you have 3x, if x is equals to 30, it means 3 multiplied by 30, and that is 90 degrees. But according to the question, it is find the value of x. That is how the value of x can be obtained. But in some other cases, you are going to find that to say x is inserted that way, then it means you are going to be told to say find x, hence find the size of each angle. Then that way it means you have to do what? To substitute. And substituting is what all that a problem, where you have a 3x there, and if x is equals to 30, it means 3x leads to 3 multiplied by 30, and you come up with a 90 degrees. And where you have 2x there, this is 2x, which leads to, it means 2 multiplied by value of x, which is 30, and this is going to be 60 degrees. This is what I'm saying. And where you have a plain x there, x leads to x, it means we have only one x, which is 30, and this is equals to 30 degrees, of which if you can add the three angles, 30 plus 60 plus 90, you can get 180 degrees. But according to the question, find x, x is just 30. I'm sure that is understood. Allow me at this point in time to take you some steps further in mathematics, so that we look at the parallel lines and the angles formed by parallel lines. What are these parallel lines all about? Parallel, once you hear of parallel lines, these are straight lines that maintain the same distance apart, of which if these straight lines can be extended, they can never meet. So for parallel lines, if in most cases, if a parallel line, we can have 2 or 3 parallel lines, and they happen to be crossed by another straight line to cut across these three parallel lines, then such a straight line is said to be a transverse line or a transversal line. Then that way some angles are formed, and these angles must be studied properly, such as alternate angles, vertical opposite angles, opposite interior angles. So it is very important to understand the parallel lines as well. So these parallel lines goes as follows.